Imagine walking into your favorite coffee shop where an AI chatbot remembers your favorite drink, suggests you the perfect snack to go with it. No waiting in line, no confusion, just seamless personalized service. Hello everyone, my name is Sapna and this is Group Husky 2. Today we are excited to present our final project, an AI powered coffee shop chatbot. AI chatbots are transforming customer service across industries. So we thought, why not bring this automation into our coffee shop experience? So why do we need a AI chatbot? It's simple. We need to enhance customer experience in every field. So let's see the trend of coffee shops over the time. Back in the day, coffee shops were simple black coffee, cappuccino, filter coffee, but there were long queues and inefficiencies. Today, coffee shops offer an overwhelming variety of choices. There are a lot of syrups, choices in milk, we have flavors. And this has not only created confusion, but also customers face delays and it's a hassle. So, how does the future look like? Future is about personalization and automation. Imagine a AI chatbot that remembers your preferences based on your past orders. It will suggest you a drink and it can also take your voice orders instantly and create a fast and seamless experience. Now, we haven't built all this yet, but our team has made a great effort. Let me show you what we have come up with so far. So as you see, when the question is not related to the coffee shop, it will give you a predefined answer. The recommendation engine works very accurately. When you ask it to recommend something, it will only give you some recommendations. And when you select something, it has put it into the cart. It will give the details of the order as well. So when you have added a coffee, I mean a cappuccino and a biscotti, it has added it to the cart and given you the prices and asked you if you need anything else. And that's how you can place your order using this chatbot. So what we aim to achieve. Now that you have seen our final product, let's explore the key features we incorporated into this chatbot. So as you see, there are five key features. Multi-agent system. The chatbot uses a multi-agent system for tasks like natural language processing and efficient order management. We have smart recommendation system as well, which will offer a personalized suggestions by analyzing the customer preferences. We have a user-friendly front end, which you'll see in a while, and we have made sure to make it scalable. So any changes would be or updates, it would be easy to accommodate. Let's move on to the system architecture. Let's walk through this architecture step by step. The architecture is divided into two main parts, development and deployment. And the second part is multi-agent and RAG workflow, that is retrieval augmented generation workflow. Development and deployment. Let's first look at the development and deployment side. The system starts with three key data sources: product details, historical order data, and product images. Product details are passed to a Hugging Face model to generate embeddings, which help the system understand the information. Historical order data is processed using a priori algorithm, which powers the recommendation engine. Product images are stored securely in Firebase. All this backend processing is packaged into a Docker container, creating a self-contained environment, and the container is then deployed on Runpod. The second part is the multi-agent and RAG workflow. Now let's move to the multi-agent and RAG workflow. This is where the chatbot's intelligence comes to life. Starting from the extreme left, you can see there's a user input on the far left. The guard agent steps in first. So it determines if the query is safe. If not, it sends a predefined response back to the user. If it is safe, the input moves to the input classify agent. This agent decides whether the query is related to an order, recommendation, or the product details and will route it appropriately to the respective agent. This agents work using trained recommendation, pulling data from Pinecone vector database and the runpod API and other backend resources to generate accurate responses. Finally, the response is sent back to the user. All this complexity is wrapped in a user-friendly interface built with React Native and TypeScript, ensuring a smooth and seamless experience for customers. Next, my teammate Lina will take you through the upcoming section.
Hi, my name is Leena, and I will walk you through the development workflow, building the chatbot step by step. So, next slide, please. So first is the crucial step is data collection and pre-processing. So first we focused on preparing and cleaning the structured data. So we gather the product details, historical orders, and product images. Initially, we took the data from the Kaggle dataset, and the product data were the names, description, price, and product images stored in the CSV file. And the orders were the past orders data for analyzing the patterns and training the recommendation engine. Next is the data pre-processing step. So the data underwent pre-processing where we removed inconsistencies, standardized formats. After that, we stored the structured data in Firebase for real-time access and uploaded product embeddings to Pinecone. Pinecone is basically a vector database, so to enable efficient similarity searches. Next is the next. Yeah, so this is the market basket analysis. So as a market analyst, we often ask ourselves like which items are frequently purchased together by the customers. And understanding these patterns can help business improve their marketing strategies, inventory management, and customer satisfaction. So basically, I'll show you an example for the master market basket analysis. Slide, please. So in this example, we can see that there is a set of shopping baskets from different customers. So first we can see the customer one purchased milk, bread, and cereal. Customer two bought milk, bread, sugar, eggs, and customer three bought the selected milk, bread, and butter. And fourth customer chose sugar and eggs. So these baskets provide valuable insights into customer behavior. So we can see that we are identifying the common items, which we can see that the milk and bread appear in the multiple baskets. These suggest that these items are frequently bought together, which could be crucial for the grocery stores when considering the product placements for or promotions. Can you go to the previous slide, please? Yeah. So in this, we are suggesting that the analysis about the co-occurrence as well. So next we can perform a co-occurrence analysis in this. This process involves counting how often the pairs of items are purchased together across all baskets. For example, if we find that milk and bread frequently appear together, we can remember that during our promotions. And next is the association rule. So lastly, we can use association rule mining algorithm like a priori to uncover deeper relationships between the products. For instance, we might discover that customers who buy milk are also likely to purchase bread, eggs, and sugar. So analyzing this shopping behavior through purchasing patterns allows the business to enhance their strategies and better meet customer needs. Next, I think. Yeah, so next is the embedding generation. So we needed a way to transform textual data into a meaningful vector representations. So for this, we use the Hugging Face model, that is BAI. So this step was crucial because it allowed our chatbot to match our user queries with relevant product descriptions and recommendations. So all embeddings were stored in the Pinecone, ensuring that quick retrieval and efficient chatbot responses. Thank you. Next will be continued by Rohit.
Hey, thank you, Lina. Since our data has been stored in the Pinecone vector base, so let's see how our multi-agent system has been designed. So let's see at the first as a guard agent, which basically ensures the input safety of the question, and it prevents the ambiguous queries such as "How are you doing?" or any other question sort of which is not related to our coffee shop. That basically guards the user queries. The second agent will look at the input classifier agent, which basically divides our input queries into the three base queries: order queries, recommendation queries, and general queries. And it will basically route that query to particular agent. So, for example, it routes to the recommendation agent. So that basically will take into consideration the a priori algorithms results, and basically gives the response to the user about the product they have choose, and based on that it will provide the recommendation based on the product it has been chosen. And the details agent basically fetch the uh, embeddings from the vector database, and based on the cosine similarity it will show the output to the user, basically the dynamic workflow of the rack system, and will provide the details about that particular product. And the order agent basically process the orders and add into the cart and updates the cart as users passes on the queries. Next slide. So we have developed a front-end Android application using the React Native, and we have also used a TypeScript to provide like a type safety and modern JavaScript features have added into it. We have inbuilt yeah, use the Figma template for the Android application development. We have integrated the Firebase database in order to enable the real-time data updates such as product images and product description and prices and all. Then we have a responsive design. We will see into the next slide. So let's see the demo of our Android application. So once you start, you will this is the home page. You will see all the products in our coffee shop, and then we can filter down using any particular category such as bakery. Then you see all the bakery related products. You can add to cart any product from the home page itself. You can go on to the details page and see the description and ratings of the product. You can add multiple products of your choice, and then this is the order page where you will see the delivery address and the items you have purchased, and then you can place an order. And yeah, here we go. So that's our Android application UI. Now let's see API integration and deployment. So we have established a backend API, and we have used Axios to connect the API with the React Native application, and we have stored our product images data into the Firebase and the vector embeddings into the Pinecone, and then we have bundled all the Python code into the Docker image, and we have deployed the Docker image onto the run pod, which basically acts as a hosting the RAG model, which is responsible for the scalability and responsiveness. And then we have choose run pod for the various such reasons. It is easy to maintain and very useful for the small scale AI projects. No need to set up any infrastructure. We need to do it in Azure or AWS. So that's why we choose Runpod for this project. Next part will be covered by Harshal. Thank you.
Hello everyone. I'm Harshal, and these are the limitations that we encountered during making of this project. Cold start latency in RAG model. The RAG model hosted on Runpod suffers from several delays. The first request due to cold starts. While catching and keeping instances active can reduce this latency, it remains a challenge for unique or infrequent queries. Recommendation accuracy challenges. Our recommendation system built on Apari algorithm struggled with limited historical data. Datasets impacted instability to make accurate predictions, particularly for new or infrequent users. Handling complex conversation. The chatbot faces difficulty with multi turn dialogues, limiting its ability to handle nuances or complex conversation effectively. This is a crucial area for improvement, potentially requiring dialogue statement management. Latency in Pinecone retrieval. Retrieving embeddings from Pinecone for similarity searches introduced minor delays. Optimizing indexing and database structure will be necessary to address this issue. UI responsiveness. While significant progress was made, the React Native app still faces occasional layouts issues on similar devices, which affects user experience. Further testing and optimizations are needed to ensure consistent performance across platforms. Next slide. So, in conclusion, our project successfully developed an AI chatbot for a coffee shop automation. The chatbot integrates a multi agent system, a recommendation engine, and a retrieval augmented generation RAG model to provide personalized real time interaction. For scalability, we deployed the system using technologies like Firebase, Pinecone, Runpod, and Docker. The infrastructure ensures the chatbot can handle real world scenarios effectively. While we have identified several limitations, the foundation laid by this project provides a strong starting point for further enhancement, such as improved recommendation, better handling of complex conversation, and optimized infrastructure performance. Next slide. This project was guided by several valuable resources, including Hugging Face, Llama, Pinecone, Runpod, Docker documentation, Reactive Native documentation. These references not only supported our technical implementation but also shaped the direction of our decision. Next slide. Thank you for your time.